Ladies and gentlemen, good afternoon and welcome to our webinar talks. Hope that you are all good and doing well. Today we will talk about surveillance topics. Precisely, we will talk about radar technology and its use in perimeter detection applications. A video technology expert, Mr. Tony Holloway, is our speaker today, and he will give you more details about this topic. Currently, Mr. Tony provides in-depth guidance on surveillance solutions for large global infrastructure clients and projects. He is currently working in 360 vision technology. So, Mr. Tony, are you here with us?
Yes, I am. Good afternoon. Very pleased to meet you all.
Good afternoon. Hope that you are doing well.
Very well, thank you. Yes, we're all set for our presentation this afternoon, so hopefully it will be an enjoyable 3/4 of an hour to an hour, maybe even longer, seeing how we go.
3 hours, you said?
No, we'll limit it to about an hour, I think, no more than that. But it's always a competition to see if we can keep everyone with us for the whole duration.
Okay, so Mr. Tony, I just announced your presentation. I just announced your topic. So you will share with us more details about radar technology, about its use in detection of in detection of perimeter threats and in use in applications. And your audience, remember that you have ability to ask the questions, so you can ask the questions on your right side of the monitor. So feel free to ask the questions, and Tony will feel free to answer your questions. So Tony, the stage is yours.
Thank you very much indeed. So we'll go for a screen share here of our first slide of today's presentation, which is all about radar technology. Before we get into the depths of the actual technology itself, let's just put the agenda up, because I think it's only appropriate to talk a little bit about 360 Vision Technology, who I'm representing today. We will then go on to really get into the detail of radar, the basic principles. And with those basic principles understood, we can look at appropriate applications. And of course, today we are talking about security applications, particularly perimeter and large open space, which radar does extremely well with. We have some videos to actually run with you as well. So some real images from a solution, very typical to the one you can see on the right of your screen, which is a product from 360 Vision Technology known as Predator Radar. As we go through this, of course, put any questions in, as has been announced to you. But the first bit, let's set the scene and actually look at who 360 Vision Technology are. And to do this, I have a video I'll run for you. So this will come up on screen now. And to explain who we are, well, we're actually a UK manufacturer. We're based in Runcorn, and Runcorn is up in the northwest of the UK, as you can see here, courtesy of Google Earth. The location of our factory. And it is a factory where essentially there are raw components coming in one side of the factory and finished product out the other side. Everything is designed here in the UK at the factory. That includes the manufacturer and it includes the support as well. Now, the product range we produce at 360 Vision is focused very much on ruggedized PTZ devices and fixed camera devices, essentially the edge devices for your surveillance solution. And as you can see, there are many vertical markets which our products are suitable for. They come in many different shapes and sizes, and some of those you can see on the screen for each slide that appears. And they are typically used in critical national infrastructure, for example, transportation, public space, anywhere where the surveillance product could be subject to a harsh environment. And for most surveillance scenarios, of course, there is often a possibility that would be the case. So the nature of the products in the different shapes and sizes becomes many different features and abilities. Of course, one of those today we're talking about, which is Predator Radar, where we have a surveillance product attached to a radar detection technology. So as each of these verticals scroll by, you can see some of those applications that not only standard cameras, but particularly radar could be used for. And that's what we're going to go into our presentation today and tease out the particular functionality of the radar technology and where it is appropriate to use that. And also importantly, where perhaps not to use it, because it's good to know essentially the best applications to guide the product to. But here's a little bit more on 360 vision before we get to that point. Some footage actually from our factory in Runcorn. Here you're seeing some of the production process with many products actually on test, because everything assembled at the factory from component parts then goes through a complete testing process and soak test, as you'd expect, to make sure that every product 100% is in full working order at the point of dispatch. Now, as we go through here, you'll meet some of the characters within inside our factory, and the fact that these are hand assembled in many ways. So there are mechanical devices to aid in the assembly, but all the products being put together by hand to customer specifications. So we build products that meet exactly what the customer is requiring, and that could be with the expect to additional illumination onto a product. It could be with different viewing technology, such as thermal as well as visual technology within inside the same PTZ unit. And the assembly you're seeing here, you can see bearings being fitted inside a unit using a press, and image of the open floor. In actual fact, the factory does look a little different now from this particular image, partly of course because of the restrictions we've been operating under, but also we've expanded since then, and the component area, which you've had a quick glimpse of, the parts area, is even larger now across our factory. You're also seeing here some of our capability in terms of pick and place machines, because we customize the lighting capability to match requirements. And this customization means we can put different lenses and different wavelength LEDs, lights, within inside our products to meet appropriate requirements. So just pausing here at the end of this particular show inside our factory of products which are on test, and landing with a screen that will actually give you a flavor of all the different types, really just in one slide. So this one slide has, on the far left hand side, top right hand corner there, the Predator radar. Let's just make that a little bit larger on screen so we can see that. There we are. On the hand side, we now have that Predator radar. And as we go through these product sets, you will see there are units of different colors. There are units in black and units in white, and even ones that appear to be chromium plated or actually stainless steel. That's a high polished unit at the bottom of the screen, and all the way through to the right hand side of the long range illumination capability, fixed cameras, dome cameras, etc. Gives you a real flavor of what we produce in the United Kingdom for these challenging surveillance applications. So that's a little roundup on the capability of 360 vision technology. And of course, there's much more that we could talk to you about with respect to that and all our credentials. But let's get into talking about the core subject of this afternoon, which is radar. And we'll kick off by actually asking the question, what actually is radar? Well, radar actually stands for something. It's radio detection and ranging. So the letters being picked out there to make the word radar. And that's all about measuring the distance to an object and where that object may be using radio waves. So let's look at that basic criteria in terms of, wow, how does this actually come about? Really simplified it on screen here, and I appreciate many of our audience may well be up to speed with this sort of technology, so do bear with us while we go through some of these particular parts, because I feel it's so important to actually understand the technology from its sort of basic platforms. So essentially what we're seeing on this graphic in the bottom left hand corner is our radio antenna, and the concept here is the fact that we are actually going to have some radio energy transmitted from our radar. So I'm just showing this as the burst, and essentially that gets transmitted away from the actual radar into the sky. So this is radio energy. It's a certain frequency inside. It depends on the actual radar technology as to exactly what that frequency is and the type and the wave. But let's assume for now that's a burst of energy that goes into the sky. Now, If that actually hits something that was in the sky or on the land, etc., it can cause an echo, and that echo can find its way back to the receiver. So the principle here, looking a little bit closer, is we have our radio antenna, our radar antenna, and if there is an object in the sky, so in this case perhaps an aircraft, when we send out our burst of energy, so it will leave our radar, propagates through the actual sky, and if there is something there, such as an airplane in this case, it will hit that aeroplane, and the aeroplane will reflect some of that energy, and part of that energy will find its way to the radar. So essentially what we have here is energy being transmitted into the sky, and we know how long it takes for that energy to propagate through the air. So we can make a measurement of time based on the fact that the energy is coming from the radar, it's reflecting onto our target, it's coming back to the actual radar. Measurement of time, we can calculate that into range. So we have the ability of working out how far an object is away from the radar based on the time taken for the information to come back, or the reflection, the echo, to come back to the radar transmitter. We can also work out the size of an object, or we can roughly estimate the size of an object. So in this case, a small aircraft perhaps that receives some energy, because it is only small, the amount of energy it will reflect is therefore a smaller proportion. Whereas if the aircraft is much larger, the amount of energy that it would reflect, therefore proportionally, would be larger. So quite a simple calculation really, on the basis that if an object is larger in the sky, it's going to reflect more, and if it's small, it will reflect less. So we can get an idea of how large the object is that's being picked up by the radio energy. Of course, this is also with respect to how far away the object is, the target is, because obviously it's further away, it will be smaller. So we're combining those two things together, the time to propagate the energy, i.e. how far away it is, the range, and also the amount that's being reflected, an estimate on how large that target is. So summarizing here, essentially, the larger the object, we can actually work that out. The third part of the puzzle is really about bearing. So if we know how far away something is, we have an idea of how large that is. The next element to say, well, exactly where it is. Of course, if it is aircraft in this simplified example, they tend to be moving if they're in the sky. So they're never actually in the same place. And what we also have is the ability of the radar is to move the radar from one point to another, typically in a circular motion. But if our targets are in different places, then we'll also find the radar is picking those up in those different places, and that's giving us our bearing. This probably makes more sense when presenting it with a traditional image of a radar, typically that you make at an airport, and of course that is rotating. Typically the classic display that you see, green with dots on it and a sweeping beam going around the outside lighting targets. So essentially we've worked out our three components, and those core components that we're bringing together, detecting objects. Now, in the solution one of looking at objects such as planes, ships, etc., most was fitted with transponders, so they actually receive radio energy from a recognize the fact that that is a liner aircraft, and they respond with information as to who they are and where they are. But of course, in a security application, we're not expecting, so we are relying on those core principles of range, size. Let's take a look then at this technology in terms of the form factor of radars, because they're not all like the ones that we've seen there on an air. We're looking from a security point of view, which is particularly much closer as far as range is concerned. So the form factors are essentially a flat panel style radar that's not moving. So it's in a fixed plane, sending out its radio energy in a point and looking at a very specific area. We can then have a radar solution which is multiple flat panels. So they would be perhaps in an array, perhaps a circular array, to actually give us the ability of covering a much larger area with flat panels. And we also have the rotational variation, which you're probably more familiar with. And on the far right-hand side there, we see the classic radars that may be on board a vessel, for example, as in a ship out at sea, having that style of communication on board. For security, much smaller and tend to be in a dome style arrangement. So the units we see there, one an inverted and upright rotational radar. So this is where we have the waveguide essentially inside the radar with perhaps a series of reflectors, and it is rotating through 360 degrees along the same lines as that first radar that we talked about. So we're dealing with those two main form factors of fixed and rotational radar. Continuing the principles of radar, let's get a little bit deeper in terms of the technology, because what we have sort of demonstrated so far is really pulse radar in saying, well, we're sending out a burst of energy. But in the security application and others, the radar technology does tend to be what's known as continuous wave. So rather than sending out a pulse, it's always sending out a wave of information, and there's information coming back as well. There is also a capability known as Doppler effect. Now, Doppler effect is a way of measuring if something is moving when it's actually being reflected upon with the radio energy. So we've inserted the image here of the emergency services vehicle, and that's really to note the fact that Doppler effect is about, if you're familiar with vehicles, when their sirens are on and you can hear the sirens, when the vehicle is approaching you, there's a certain pitch that you hear of that siren. When the vehicle passes you and is then moving further away, the pitch of that siren actually changes. Of course, the siren itself's pitch doesn't change, but what you are hearing is actually changing because the vehicle is physically moving. The wavelength that you're receiving is different. That is essentially Doppler effect. So a waveform is being sent out by the radar. If it hits a target which is moving, the reflection will modify that waveform, and we can detect the modifications in that waveform to estimate whether a target is moving towards, away, and potentially how fast the target is moving as well. This can be further mixed in with frequency modulation continuous wave. And that's mixing more in terms of the frequency modulation enables us to change the waveform really as a time marker. So we send out the waveform continuously, but we change some of the timings within inside it, and that gives us the ability that when the reflections come back, we can compare when the timing change was done as to when we sent the waveform out and when it was received. Therefore, we have that range measurement. So there's quite a bit there without getting too deep into the complexities of radar, which is used with inside security applications. We also do have to mention, of course, radar is actually a very sophisticated tool in modern times. Example of this vessel, of course, has multiple radar technologies for doing a number of different things. In some respects, they are for actually detecting targets at great distance, and then there are different radars which are used to get further detail about those targets, essentially turning the radar in a fixed position to the particular target so they can work out the exact size and stream and maybe identify even the type of target, as well as having countermeasures on board. So there is ways of actually deploying technology that will confuse radar. So if you are potentially being detected, make those radars bounce off. I'm sure we know of the term stealth. And that even comes to the point of aircraft, of course, where the design of those is such that radio energy actually bounces off the surface or is perhaps absorbed by the surface. Again, things that we don't need to be hugely concerned about from a security point of view, but it is worth knowing all security applications have an Achilles heel somewhere along the lines. So interesting just to sort of tease into that. But let's just get back to the security application and look at, well, why we want to use radar for security. Well, there are many reasons where it really brings an advantage to the table, particularly, of course, cost. It's always about cost. We're looking for the most economical way of protecting a facility, and radar has got superb range and it operates in all weather conditions. And it doesn't matter whether it's dark or light. This isn't the technology we're using in terms of radar. It doesn't have that impact at all. It's very good, of course, at detecting moving targets. And in security applications, that tends to be exactly what we're interested in. We're interested in people approaching a site, perhaps. We're interested in vehicles approaching a site. We're interested in the movements within a site. So it's that sort of thing that we're interested in as far as sites are concerned. Changes, which mean movement, and people tend to be one of the main threats there. And so we can detect when people are moving around or approaching site, and anything larger than that, such as vehicles, then that is a useful device to have in play. Radar can also complement many other detections on site, particularly as far as perimeter security is concerned, because there are other types, of course, be it forms of wiring on a fence, wiring within a ground, motion detection sensors, be it video analytics through thermal cameras and visual cameras, quite a mix. These things can actually complement each other, again, having the radar provide an automated capability. And with the different form factors, you can be very specific, covering hundreds of meters with a single radar, or in the 360-degree capability, a vast area indeed, where other types of detection technology may struggle or become cost prohibitive to cover that particular area. So really good at detecting large open spaces, which can be quite challenging. Radar technology, very low power. So there isn't an awful lot you need to actually power the units up, which opens radar technology up for being in off-grid and wireless solutions, should that be appropriate for the application. And because we have such a great area that we can cover, you can reduce the amount of infrastructure required for fixed installations. Again, a benefit in terms of reducing costs for those where you may be looking at putting multiple other types of devices in place that all need infrastructure to be physically mounted on, in addition to power and communication, of course. And the radar technology can be integrated into alarm management systems, video management systems, etc., for application. So to give just a quick example of a typical application for a radar, it could be as shown here, just a yard, a large open space. What are we looking for a radar to do? Well, we're looking for it to detect anyone that's moving in this particular area. So here's a quick video that just shows that example, essentially, of our looking at an entranceway to a facility, and when there's an alarm triggered by the radar then takes the camera, it slews the camera to the target, which has actually caused the detection. The radar continually monitors where that target is and updates the surveillance solution to actually follow that particular target. So in this case, it selected the camera, it turned on the white light, it highlighted the particular intruder. Of course, in this case, it's a demonstration. Not many intruders actually come in with high visibility vests on. But you get the concept here. It's a large open space, very easy for the radar to detect movement on that particular space. So applications for radar, and we're looking at many where it would be suitable. So typically, as we've seen here, 6 put up on the screen, but by no means exhaustive. Anywhere where there is a large open space. So airports, of course, are a classic area where they have huge space where we don't wish to have people wandering around, and we certainly need to detect if anyone has decided to go into that particular area. Construction sites, such as mining, as we put here, areas where the land changes quite regularly. Large construction materials are being placed, moved around, as well as plant machinery, for example, making it a little difficult to put in more traditional security apparatus, where a radar, as long as it can see essentially the whole area, then it can detect what's actually moving. So when you're in a lockdown situation of nighttime and the security have come into place, then the radar can busily monitor if anything moves on site where it shouldn't be. And the other examples we see here that could be challenging in terms of putting in a low number of detection devices to cover a large area. Of course, excellent in solutions that may have a sterile zone, such as prisons, where there absolutely shouldn't be anyone at all, and any movement within that area should be brought to the attention. But there's something else here which is also important, because typical fence line perimeter solutions will look purely down the fence line. Whereas the radar, if it's in 360-degree mode, will be able to look into sight and away from sight as well. Now, that can be really crucial, particularly in having early warning that someone is approaching site. If the site is a utility site, for example, and some of those are essentially in remote locations, no one should be really going near them. So having a system that will give indication when someone has come within a few hundred meters of a site when there's no real need for them to be there can trigger the ability just to look with, well, what are they doing? Is it someone that's just gone for a walk in the countryside, walking the dog, for example, or is it someone or group of people that look potentially suspicious? So early warning available there before they ever come anywhere near site. And if the worst should happen where someone has penetrated sites, your classic perimeter system, of course, will give you an alarm that someone has actually entered the site. But once they're within the compound, do you have detection devices to continually monitor where those people, objects, vehicles are? Well, the radar, of course, can look into sight as well. Therefore, if someone does breach a perimeter, it could be live tracking that person as they make their way throughout a particular site, providing video evidence if linked into the camera, but actually providing precise information of their location in terms of detection of movement. So really powerful in terms of taking radar and sort of 360-degree to provide a comprehensive automated monitoring facility for a secure site. Some other applications for radar technology, and there's quite a few here. One in particular would be traffic. It's something that's been trialed for many years. The ability of having a radar, in this case, is not really looking at intruders, for example. We're looking at traffic flow. And this could be for congestion monitoring purposes. Again, large area can be monitored, multiple lanes of a highway, using radar to work out when the traffic is slowing or the traffic has stopped. And particular, as far as stopped is concerned, stopped vehicle detection, when you have motorways with multiple lanes and a vehicle stops in one of those lanes, having the ability for that to be automatically detected, and therefore automation can be put in place to close that lane to provide safety for the vehicle and the other road users, that the lane has been closed because of a broken down vehicle. This can be particularly useful, of course, in tunnel applications, which can be very narrow, very long, and incidents can take place where the radar can detect if something has become stationary. So there's traffic, but there's also perhaps drone detection. Different types of radar technology you would use for these, but the principles are the same. Drone detection, it's something which is entered, of course, the security marketplace. There are multiple threats provided by drones, as well as, of course, huge benefits by having such devices around. But their ability to be so small and agile and enter sight somewhat freely, the ability to detect those and the nature of them and what they're about is absolutely critical for many sites. So radar technology is one of those that can be used for detecting devices in the sky. I stress these are different types of radar technology along the same principles, but tuned specifically for those applications. And the final one to point out here is traffic monitoring from a rail point of view. So we're looking at those junctions where people, vehicles and rail all combine, such as level crossings, the ability to always monitor whether the track is actually free from obstruction. Again, the idea of having a detection device that isn't affected by the weather and the light, etc., and can work out exactly whether something is stopped or moving in the way, provides a real benefit in terms of continual real-time monitoring, such as in these applications. So looking further at the application of radar technology, let's go through some of the pros and cons in terms of actually saying, well, will it be appropriate for the environment? So there's quite a piece of a literature available about the application of our radar technology. But first, let's tease into some of these elements along the understanding of its basic application. And the first thing is in terms of the mounting height of radar. Essentially, the technology is this radio beam, which is coming out from a circular or fixed radar. Of course, it's coming out somewhat in a horizontal fashion from the radar itself. So we are looking not in the sky in this particular application of security, we're looking across the ground. So we don't wish to be too high from that point of view. So typically 3 to 4 meters mounting height for a radar unit. It can be lower, it can be higher. We're looking at the ideal mounting height to provide a range of detection capability. And also bear in mind, in terms of radio technology, we're looking for that reflectance off of targets. So the radar technology doesn't go through any target. So the frequency we're using here, we're looking for reflections, not penetration through anything. So you should really look at the viability of radar from the basis of that you can see. So if you're at a location and you're looking at a site, what you will see is what the radar will see as a good rule of thumb. So taking that particular idea in this from a terrain point of view. So if the land goes uphill when there's some hills, the radar won't see behind the hills, just as you can't from your point. And it will be if there's any dips in the terrain as well. The radar energy will not go into a dip necessarily and actually have a reflection coming back. So you're looking for a fairly level area. If there are terrain fluctuations, multiple radars could actually be used. And it doesn't actually necessarily need to be level. You're looking for a flat area, but it doesn't have to be level, as long as the radar can be mounted in such a way as that it has range that fits with the lay of the land for the site. So bearing in mind here the distance the radar will be able to travel and whether there's any objects that essentially will stop it going any further. So we've mentioned we can't see through anything, and the radar technology is all about bouncing that radio technology off of items of interest. So everything essentially which has great reflectance, such as metal and buildings, etc., will provide information coming back to the radar. Now, information coming back to the radar that we're not particularly interested in, and so for a security application, that's anything that essentially is stationary and isn't moving, we would refer to here as clutter. So clutter coming back in is information which is bounced back to us, but we just need to ignore it. It's not relevant. So concern needs to be shown for sites that may be highly reflective. So image of a car compound here, which I do have some video on for a little bit later in our presentation. You can see here that lots of vehicles of lots of reflections, glass, metal surfaces could provide quite a bit of clutter, could be a little challenging, one worth bearing in mind. Another one which must be considered is vegetation, things that are moving that we're not interested in. So that could be big trees, for example, that are moving. It could be other machinery which is moving, which is not an intruder in any way, but that's part of the particular site or application we have in mind. So if something's moving and it's within the range of the radar and it's in a detection zone, the radar may say, hey, there's something moving there. So important to mask off areas where there is movement within inside a radar setup. So typically here, vegetation, large trees, etc. Radar will detect movement within inside these areas, but on a very windy day, of course, you're going to get information which you're not interested in about a branch of a tree moving. So care needs to be taken in the application of radar in these sorts of environments. I've already mentioned as well, reflections a few times, and reflections do need to be very carefully considered. In this particular image, we can see two individuals in the middle of the screen. They happen to be tracked by the radar. We'll just take a look at this piece of footage in a moment. This is particularly challenging because within the range of the radar, we have some very large flat-sided buildings, industrial units. We have vehicles, we have some bins, etc., in place. And of course, the radar energy will be bouncing off these, and they could cause a reflection. Now, let's just look at this a little bit closer in terms of a reflection. Firstly, familiarization with a piece of video. So what we're going to see here is a radar just tracking some individuals, and as they make their way, as it happens to be, this is in Runcorn on the goods entrance of 360 Vision Technology, and we can see our individuals walking along the rear of the building here, and the radar is busily tracking them without any trouble at all. But this is in actual fact a little bit of a challenging environment, because let's take a plan view of where we are here. So the yellow dot on screen towards the bottom is where the radar was located, and our targets, our people that were walking along, is our orange arrow towards the top. So as they're propagating along, our radar is busily spinning round. So our radar is in a circular motion, and it's sending out its radio energy. Now you can see here from the place where the radar was, behind the radar, that's just a wall essentially. It's the side of a large building. It's wall and fabrication of that building itself. And then we've got, to the far side, another building. Well, we do have clear line of sight between our target and the radar. So there's our green line on screen. We are clearly detecting our target, as we've seen in the video, and we're tracking our target without any trouble at all. But do bear in mind, at this moment, there is going to be another path, because once the radar has rotated, there is another path for radio energy, which essentially reflects off the remote building. And you can see here that path on the red arrow is longer in distance than on green arrow, and essentially would give us a false reading. It would make us think that our two people are actually inside the building opposite. So this is a simplification of potential of reflection, but it's worth bearing in mind when using radar in built up areas, depending on where you actually are, the detection items, the targets that you're looking for, to ensure you do get accurate readings of exactly where you are. Well, the video there actually shows it, and we'll look at the full video a little bit later on. And naturally, we've set the radar up that this potential reflection is inside a building, so ignore anything that's inside a building that you possibly couldn't see. So easy to come by. And mitigate, but important to understand that differentiation in terms of installation. Something else to be wary of, and again, along the same lines as already mentioned in terms of what you can see and what the radar can actually see. Here we have a typical fence line, perimeter security. We can see through the right hand side of that fence line. So whether it's a chain link fence, a palisade fence, or a welded mesh in this particular case, we can see through this quite well, and we can see a vehicle on the far side. But to the left of this image, again highlighted by the red circle, our fence line becomes dense because of the angle that we're looking into that fence line. In most cases here, the vertical posts supporting that fence line actually become a barrier. So the radar itself will be reflecting off that fence and not actually seeing behind it, if we were to place the radar in the position shown within this photograph. So for perimeter applications, we would actually stand the radar off back from the actual fence line itself, or we would place it exactly on the fence line, in which case it would be monitoring in both directions and 360-degree radar to do this, or it could be a fixed panel radar essentially within a sterile zone of the fence line to monitor anyone which approaches it at that particular point. So worth bearing in mind in terms of placing radar, any masking effects that could be created by the surrounding area. Something else to be notable of is when looking over water, so be it streams, rivers, lakes, etc. The ground-based radar for a security application is looking at movement. So again, when the weather's up and there are lots of choppy waves and wash, etc., then you may get false readings from the radar. Having said that, we have set radar up over watered areas such as here, and it can be fine-tuned to operate very well indeed. But something to be mindful of again when actually involving water in radar detection solutions. So we also have the thought of weather. Now, weather in itself doesn't really affect radar, with the exception of very stormy weather, which could essentially reduce the range capability of the radar, possibly interfere and give false alarms, etc. It is possible to tune the radar to operate within inside these environments. Something we can show here just very briefly actually is a radar operating in full snow conditions, which is again quite a rare sight, where we have on screen here a radar unit. You can see that the purple area is the detection zone, and to the left we can see it tracking a vehicle, a green vehicle. Snow is all around, and it's currently snowing at this moment when the radar is operating, and this vehicle is approaching the radar. We can see it bring it in to focus. So really all weather operation, with that little caveat about extreme weather, which may reduce the range of the radar, which of course, again, if you were comparing that with other technologies, when heavy wind and snow comes down, video analytics, things like that can all be compromised. Let's take a look more into the design and then appreciate even further what the radar is potentially seeing from an application point of view. So here is a typical clutter scan on a radar. So our radar is in the center of the screen. This is kind of the classic look that you may be familiar with. And what we're seeing here is a varied level of reflection. And we can see essentially some brighter green areas around here. If I put this into context of the background of where the radar actually is, then we can see we're on essentially a housing estate, an urban area, and this is a park area which the radar is actually placed in. And the darker areas around the edge of this park area are actually, if I lighten the background up with this particular slide, you can now work out the fact that there are trees all behind. So the radar technology from where that radar's placed is reflecting on all those trees. So this will do a very good job at actually monitoring anything that moved within this park area. But beyond there, you've got some trees which are of course going to be causing some masking, and you also wouldn't be wanting those trees to be within the detection area, because when it's windy, etc., they may well give you false alarms. But you would very competently monitor any movement within the park area we see here. So in terms of designing the radar and putting it, knowing whether it's appropriate for an application, we can put it into, courtesy of Google Earth, as we've seen here, onto essentially a plot to work out capability. So you could pick a particular site. So here we're 360 Vision's office in Runcorn, and we suggested as a radar, not necessarily in a position you would practically put one, but we've just put the radar in the middle of this particular estate. And then we're marking up on screen the actual maximum range of the radar. So this particular model has a maximum range of 200 meters in terms of a radius. And so we've marked on here on our Google Earth plot exactly where that possible theoretical maximum range would be. The reality is two things. There are objects in the way, and there's the lay of the land itself in terms of that terrain. So if we actually fill in this particular area with a layer, we can see the red, which has been put in place here, and anything which is going through that red is essentially going to be in the way of that particular radar's field of view. And of course, we can see all the business units, the industrial units, with all their roofs are going to cause some blockage in terms of that radio energy as far as detection is concerned. So we can very easily, using these tools, actually reduce that down to what is realistically the radar likely to be able to see. So we're still at the oblique angle here. So let's actually turn that up to a plan view. So on our plan view, there's our radar marked up with our little yellow place marker, and then the red area is, in theory, what the radar will actually be able to see from that location, based on the fact that it is not seeing through those objects, and we don't wish it to see beyond tree lines that can cause false alarms, etc. So a really good way of working out the sort of coverage you can actually get with radar on a particular site, using obviously modern tools. Let's look particularly then at the combined solution in terms of radar and security, and we will be picking particular, of course, on a 360 Vision product known as Predator Radar, which is available in different form factors. You can see it just on the left hand side there for various markets, but we're specific today looking at perimeter and site security. So the model in question, on the left hand side of the screen, is in a particular form factor which is relevant to everything we've been talking about, I've been talking about so far, which is essentially radar. It has a full 360-degree capability, and it is mounted above the surveillance camera. And the form factor of the surveillance camera, being below the radar, also has a full 360-degree field of view, because the head actually slews around the outside. This is an important factor, because if the technology was separate, essentially there's always going to be something possibly in the way of the radar in terms of the camera column, for example, if that's associated with it, and vice versa. If I have a camera column, you end up with at some point an area which you can't see because the radar's in the way, or the mounting structure for the radar is in the way, causing an obstruction. So with the radar technology we're looking at here, we've already said it's a 200-meter range capability. That is tuned for looking at people. So anything larger than people, essentially up to 200 meters away from the radar itself. That gives us 400 meters, essentially a fence line that can be monitored. And if we open that up, there's 125,000 square meters of coverage. So you can cover a vast area with a very low number of radars indeed. The other beauty of a combined unit is that if I am interfacing this in with surveillance cameras, we have to work out exactly where the radar has detected its object and to actually slew the camera to physically look at that object. Well, these units, of course, being combined, that is all pre-calculated together, and the radar can be programmed in such a way that it will monitor multiple targets, and you can have the radar then decide which of those targets, based on criteria that you set, the camera then looks at. So, for example, whether it's the first target that turns up or whether it's via priority through a number of different zones, and of course schedules as well as to when you wish the radar to actually be live and monitoring targets. So you have the power there of the actual radar itself, it being combined with the detection viewing capability of the actual camera package. So this particular Predator radar is available whole host of options. Lighting, so you can actually see at 200 meters from the camera in total darkness, obviously important for that visual verification. The combination of thermal camera technology, should you desire, so again you can increase that range and really pick out items which may be approaching and have been detected by the radar, as well as perhaps color coding the radar itself so it blends in with a particular site in question. It could even be put on a wireless capability. So the whole assembly could be put on a cellular transmission and could also be powered by solar battery for remote deployment. So a really powerful solution. So in terms of complementing that radar, let's just take a look at video performance, what you would expect, and let's look at what 200 meters is. So if we're saying we can detect a person at 200 meters, we want to be able to have visual verification of that 200 meters as well. So here's a wide angle view, and right in the center of the screen, there's a couple of individuals holding up a plaque that says 200, that's 200 meters. And if we zoom in to those two individuals, we can see them there. This is a 30 times optic package, and they are about 40% of screen height, which in terms of pixels on target, you're just about in the classification of being able to certainly recognize those individuals, if not being able to actually identify who they are, and that's at 200 meters. Similar, if I was looking to actually pick up identification perhaps from vehicles, for example, again zoomed in at the point, these vehicles are 150 meters away from the camera, and we have sufficient capability to easily read registration plates and other identifying information about vehicles and perhaps people that are in the area. That's daytime. We're interested, of course, in nighttime operation. So we need 200 meters of illumination. And in this example, we're showing a target in the dead of night. Target happens to be at 90 meters, but the actual area where we're doing these tests is much greater than that. Happens to be a ground where there's no one else around. Very late at night, you can see the cricket gun has a 200-meter visual range. So our radar essentially tracked out of that distance, and we could provide illumination. In actual fact, more impressively with this particular image, this is using IR illumination at night, which is our no glow illumination. So that's 940 nanometers. So it's so far up the range as far as IR illumination on CCTV is concerned. Typically you see that red glow when you actually look at the illuminators, the LEDs, the lenses. You don't see that with this product. It is completely covert. It's totally dark, so you can't tell the unit's on. Really important, particularly if you have a radar on a particular site and you want to maintain a covert nature of the unit, that you don't have this red glow obviously spinning around on the particular radar itself, if that's not a requirement. And we can see from here, this is super dark in actual fact. If this particular image was taken without any illumination on, hopefully you might just better make out there's something in the middle of the screen illumination back on again, we can now clearly see our test target using that 940 no glow. Another option with the product range is white light, as we saw on an earlier video. If you get a detection, you may wish the radar to command the camera to turn on a white light, which in one respect would certainly inform someone that they are under surveillance with that white light shining at them. If it's completely dark like this, that could be quite a shock when that white light gets turned on. And the white light also brings the benefit, of course, of providing a color image of the surveillance footage for that period of time when it's actually turned on, as we can see from our test target. And I did also mention thermal capability. And again, when you bring this in with a surveillance setup, you could have the radar detect that there's movement on a particular site. It will bring up the image. It will guide the radar around. It's got to guide the camera around to show the area, but it may be not so obvious where that person or vehicle is. But when you combine that with thermal and with techniques you can use on that thermal camera in terms of highlighting the heat source, then you have that double verification that the movement that you see is a person outside a vehicle walking around an area perhaps they shouldn't be from this point of view. So adding in all this additional capability enhances the radar's detection capability in confirming what that detection is. And in setting up the radar, here's a typical output of an example unit. Really straightforward in as much as you have that map in the background. So again, it's your assistance of Google, really, having that map in the background and being able to mark on the map areas of detection. So out of the box, the unit could be full 360 degrees worth of detection, and you can narrow that down and just draw some polygons on and cut some spaces out, etc. As far as this is concerned, anywhere which has the sort of a purple on it is a detection zone, and then you've got different priorities that can be programmed into the unit and how it responds. So that's quite a bit of me talking at you, a good 45 minutes worth plus of me lecturing you about radar. So let's finish up on a little bit more video here in showing radar in operation. And this first example I want to show you is really sort of bringing everything together we've seen so far. And this is with a radar temporarily just mounted on a vessel on the River Thames, and it's monitoring the river traffic, essentially the shipping lanes, and it will demonstrate to us really the ability to start with in terms of showing the radar in operation, tracking objects in various different directions on the River Thames. Of course, that's over water, so we've got the wash, etc., to contend with. So just setting the scene there. Mounted on the left-hand side on that vessel, you've got the width of the shipping area, and now you can see the main video image itself, and it's just slewed the actual camera round to look at our first vessel. So inside this video, the top right hand corner, you're seeing a video insert of the actual Predator radar itself, so you can physically see it moving there as it tracks this vessel, as you can see on the main video output. And then in the center of the screen at the top, you can see the radar output in a graphical form from the unit, and it's been set up very straightforward here. There's only one zone. Of course, we can have multiple zones, but this has been set with one zone, and that zone has one priority, and we've essentially told the radar just to track the first target that comes in and make the camera look at that target. It's also tracking anything else that actually moves within inside that zone, but it's not a priority for us. We want the actual camera to be looking at the first target. So it will continue to look at this first target, even though there is another target making its way upstream. So essentially, primary tracking, as we call it, the first target into a zone of that priority, then the radar stays with that. Now, as that vessel moves further away, the camera zooms in a little bit onto that vessel. It will eventually go out of range, so beyond 200 meters away from the radar, at which point the radar will decide the next most appropriate target in level of threat. In this case, will be whatever is closest to the actual radar itself. And so you can see in this view here, there was a much closer target at this point, which happened to be this blue rib making its way upstream, quite close indeed to the actual radar. And as it makes its way past, we will continue to track the blue rib all the way upstream. So this is really demonstrating in a kind of straightforward straightforward method. The fact that we have got that one zone and we're tracking targets within that zone, we're pushing the radar around, so we're pushing the camera around to actually look at those particular targets, giving us that visual verification of where they are and where they're up to. So a good demonstration of radar from that point of view. Let's look at another demonstration where we're going to be changing the priority of the actual targets. So in this piece of video, we're going to show you we're still on the River Thames. And this time we're actually zoomed in a lot closer to the particular vessels, which is also something that can be changed on the unit as to how close you actually want to zoom in. It's all automated. And you can see here we're very close in on this particular tugboat making its way downstream in this case, slightly more choppy in terms of weather. And we can see on the inset from the radar itself, we've got 3 zones set up. So we've got 2 high priority and 1 low priority. And this tug is currently in a low priority. So if there's nothing else happening, then look at the low priority. As soon as a vessel enters the high priority, we switch to that vessel. So we're still tracking in all areas, but we're having the camera look at the high priority vessel as that being more important. Now, in actual fact, this is quite a large vessel indeed. So you can see with the colored traces that are on the radar output, it actually looks at it and it says, okay, there's various things happening here. And this is so large, it's possibly 2 things I'm looking at. So it actually puts multiple colors on the particular vessel in question. But even at this point, you can see it actually sticks with that as being the most important target within inside this high priority area, and it continues to track that vessel as it makes its way upstream whilst picking on other targets as well. And fairly challenging because we've got the wash coming up there that these vessels are actually creating, and as every vessel goes past, because the radar is physically mounted on board a ship itself, it's not in a fixed location either, so there's a bit of movement of the actual radar that it's having to contend with as well. And we can see here, as just mentioned on screen, once it's out of range, the radar then goes back and selects a lower priority target that as there isn't any high priority ones around at that moment. So that gives you really a summing up of radar technology in operation from the point of view of, picking large vessels and moving. You can see it from that point of view. But from a security point of view, we would perhaps be more interested in an application such as this, a large compound, and a large compound in this case filled with vehicles which are awaiting dispatch. So this large compound happens to be at the docks, and the vehicles are being held here. And of course, with them being new vehicles, there's a security risk here. Multiple, of course, in terms of someone perhaps helping themselves to a vehicle, or maybe coming in the dead of night under the cover of darkness to perhaps see if they can help themselves to other valuable parts of the vehicles. So a radar, very powerful in this particular setup. Tuned to actually detect anyone that moves within inside the compound, and it is actually picking up people that are moving within inside the vehicles. We can just see someone there in the middle of the screen next to the transporter collecting vehicles, and it's their movement that's got the radar's attention. But as some vehicles now enter the compound, and naturally this is operating in the daytime with daytime movements as far as this compound's concerned, the radar is now following those particular vehicles as they move in to the compound here, as well as monitoring the individuals that are also moving within inside the compound. So we've got these individuals in the high visibility jackets moving around. Everyone becomes a target if they're moving. The radar is set up to look at all of those targets. So it was a timeshare between everything that's moving on this site. Now, typically, this would be in a nighttime operation, when no one should be moving on site. And we're really interested in anyone entering this compound. So you can see straight away the capability of the radar to survey a very large area indeed, and potentially zoom in on those movements should they actually take place. But in addition, the radar can also be used to monitor outside the compound. So depending on our fence slide, as we talked about here, the range of the radar can see if anyone perhaps is approaching, because again at night there may be areas on a compound where there really shouldn't be any movement, but if there is, we're interested just to see who may be getting close to an area, and perhaps intelligence gathering, and the radar can pick up on those movements in those particular hours and keep security personnel well informed of what might be happening. No direct threat because no one's entered the compound, no actual thing has happened, but it's just additional information that can be gathered from the area of the particular site in question. And you can see here the radar will happily do this all day long, of course, 24/7, tracking people and vehicles. And so here's another 2 vehicles which have entered into the compound, new targets. And so the radar picks on those targets as well, and it'll follow them round just as it did before into the particular parking areas where they're going, and any personnel that might be moving, you'll track those as well. I'm sure you get the idea of how this operates. As you can see, there's another video on screen here to show you something slightly different again. This time over water, a very calm day, but a challenging application where the radar is looking over this still area which has birds, etc. We've given the radar a park position to say, okay, if nothing's happening, just look across the waterway. And this little snippet of video is quite good because the radar has been triggered and it zooms the camera in. I initially think, oh, perhaps it's those birds, because birds could potentially trigger a radar if you've got it too sensitive. But not in actual fact. What the radar has actually picked up is 2 people. And they're just behind the bushes on the left-hand side. So it's picked up on those as a target. And as they're moving, we can see the radar says, okay, well, there's the target. We picked on that target. Radar is about to time out. And so it goes off back to its home position, at which point the target splits because it's 2 people, and it goes straight back and then picks up on the fact that there's a new target that's just appeared. So again, it just a little snippet there shows you one of the features in operation of the radar we sat there. And there were 2 other videos that we did see earlier, so let's just look at, I think, the yard we already saw previously, but let's just run this one again, which is the tracking of some people outside the rear of the 360 Vision's office. And we talked about the reflection and being able to tune the radar so you eliminate those reflections from challenging applications. And here we are, it's that same piece of video running, and this time we'll let it keep going, where we see our 2 individuals actually make their way all the way past the rear entrance of the office. And incidentally, as this is happening, they walk behind these biffa bins. Of course, they're out of radar range at that point because they're masked by the bins as far as the radar is concerned. So as they go behind there, the radar doesn't move. But as soon as they appear behind those bins, it locks on straight to them and continues to actually monitor them. And there are various radar technologies on the market, depending on how complex you wish the actual algorithms to be in terms of the sort of tracking capability that's available, as to whether there are people or vehicles and ranges, etc. So what you're seeing here is really a taster of a very cost-effective solution using that radar technology to monitor targets. And in this case, our volunteers make their way out to the other end of the estate area, and our demonstration is done of that capability. So let's round up really what we've been talking about, and hopefully you're all still with me, and I'm very grateful for your time this afternoon. So what have we talked about? We did talk about very much understanding the design of radar and the technology behind it, which is really important to make sure that it fits application. And that's very much about understanding the application that you wish to use radar for. Does it actually fit? And this rolls back to what we would call the operational requirement of a particular application. So seeing whether radar in its very capable situation does fit nicely with your environment, your opportunity of being able to protect a particular site. So a list of criteria there, and understanding how radar works. Of course, we focus quite a bit there on the Predator radar, which is about the combining of surveillance capability with radar technology capability as well. So at this point, we will open this up to questions that may be there. Hopefully there's a few that will actually come back in. We'll settle on our final slide of our groups of images. Are you all still with us?
Hello, Tony. Can you hear us?
Hello there. Yes, we have
Great.
you. Hopefully you continue to hear me.
Yes, great. Tony, thank you very much for this insightful and interesting lecture. I believe that it will be useful to most of our audience. Very nice example with those footage, and really thank you to your volunteers that did this. Before you leave, We have a couple of questions regarding this presentation. So, but before we skip to questions, I want to ask you, in your opinion, what is the limit of this technology? Not the current limit, but let's say how far it can go using
Well,
like
mm,
radar technology and surveillance.
it's very interesting because the radar technology, which has been with us for, well, from its infancy, we would say almost 100 years, but in deployment maybe for about 80 years in different types. But more recently, from a security application in terms of close security, just a few hundred meters. But it already really has been extensively developed in terms of detection. But I think what's quite interesting as far as the radar technology is concerned is the analytical engines behind it, and they're the ones which are really working out in terms of the target, how it's moving, where it's moving, predictability of where a target's actually going to be, and the intent. And I think particularly mixing that sort of capability together, the radar technology is very complementary. So I'm sure it's still got further to go, particularly when using different frequencies and multiple frequencies within inside the same unit for precisely detecting particular targets. And that does come into applications like for drone, for example. It needs to be very precise to actually monitoring those sorts. So I think it's combining those together. So it's still got a great future in actual fact. And what's really come in here is the price competitiveness of the product, where it has such range in terms of the cost base compared with other technology that's out there. So yes, it's got a long way to go. It'll be around for many, many years.
Thank you, Tony. Let's go to questions. So first question is how to reduce unwanted and false alarms.
Well, I guess we touched on some of the aspects of that can give you false alarms, such as moving items and reflections, etc. And that really is down to initially certainly not applying a radar to a scenario where there will be things moving that you're not interested in, and things that are moving, should we say, in such a way that could cause you false alarms, such as trees that are moving. So if there is an area, say, well, there's a lot of trees here, I want to have detection within those, and perhaps the radar isn't the best form, and there'd be an alternative to detection for those areas, which could be thermal with some motion detection capability, analytic for that particular area to complement the radar. So in setup of radar, there are all sorts of settings in terms of thresholds, in terms of the actual clutter and the amount of movement that a target needs to do. So in many cases, you can completely ignore low-level movement. And if I'm only interested in vehicles, you can count off anything else that might be moving on the site, such as large animals and people. If you wish, and I'm only in vehicles, you can tune the radar only be looking at vehicles. So that really does come down to the setup and spending that time, not only in the correct application of the product, but making sure it's appropriately tuned for the environment, so it only detects what you're interested in and what you may be considering a threat to the application itself.
Okay, thank you, Tony. The next question is quite similar to the first one. It says like, but let's answer it. How do we best deal with the radar detection issues such as like uneven terrain, lack of open spaces, buildings, and foliage? It is like quite interesting to the first question, as I already said, but if you have something to add, it would be good.
Yeah, I think one of the examples that we've shown in this presentation was a radar just at the goods entrance to 360 Vision office, which was deliberately done because that's not necessarily a typical environment for covering that area wholeheartedly because of the many large flat buildings. So built up urban areas aren't necessarily the best applications for radar. They really are suited to large open spaces. So terrain which is fluctuating, as long as it's not extremely hilly in terms of the elevation changes, where radar comes into play. So if you typically think of an airport, for example, they are typically large open spaces and very flat. There's the nature of the area. That's where radar has a huge advantage over pretty much any sort of other technology, sort of covering those open spaces on many areas. So I think it is very much down to application. Putting radar technology in built up areas is not ideal unless you had a very particular requirement of a particular range where you wish the radar to actually operate. Having said that, you can do it. It's just not necessarily the most most ideal application. I think you will find in doing that you could get the odd reflection or unwanted alarm, or it could be essentially a genuine movement that you see in more than one place because of other reflecting factors. But of course, we have hopefully demonstrated through some of the videos that we've shown here, effective operation in areas which are not only slightly built up, but also in large open spaces. So yeah, a similar question, but I think for me, the understanding of radar technology is what really assists the appropriate application, where you can see, yep, radar will work really well here above other technologies.
Let's go to next question. It says like, what is the main advantage of these products comparing to the conventional cameras? I suppose that.
The conventional cameras, in terms of mixing with radar technology, what we're bringing together here is a whole series of capability, which is at its best for each individual technology. So we have a radar which is thus detecting movement, if that's what I'm interested in on my application, 24/7, really not affected by the weather, not affected by lighting conditions. And of course, cameras are affected by lighting conditions, and we bring in various countermeasures to that, such as having additional illumination. But where those images can vary. So if you're combining that with video analytic, which can certainly bring a benefit, you are restricted in some certain ranges depending on the technology you're using, particularly with visual light, not so much with thermal, but again, you still need to bear in mind weather conditions and time of day and part of the world you're in from a thermal camera point of view. So I think very much it's about bringing the combination of units together. And of course, from a 360 vision point of view, we do specialize in extreme environment products, our ruggedized PTZs, not only for traditional applications, but also extremes of temperatures and harsh environments. So again, the radar being one of those products which excels in those areas, combining that with our lighting, video, thermal capability is where we really bring a powerful and capable product to the market.
Tony, thank you very much. We have one more questions. What happens if we have like more targets? Is it possible like to integrate more cameras on one radar?
Yes, it is. We focused here really on just looking at a few targets in our principle, but radar technology is available for a single radar to actually track multiple targets. So in our example, we were showing, I think it was up to a maximum of 8 can actually be tracked on that particular unit, but radar are available where they'll track way more than that, 40 targets at the same time if you require, and switch cameras between those. So systems can become more complex where we have multiple radars and multiple cameras. And at that point, you can integrate those devices together in such a way as that you're commanding several cameras to track objects. And if you can imagine a very large site where you have a target which is entered at one end, you essentially can automate the process where it hands the target over between those radars and the surveillance at the same time. So you can really lift the actual capability of the solution with multiple cameras and radars, which can be all integrated together. Of course, it's a much wider picture at that point, and it also depends on the alarm management system that you'd be deploying, but that's probably another webinar, I think, to going down that particular line to show that sort of stuff off.
Let's leave it for another webinar. Okay, Tony, once more, thank you very much for this lecture. As I said already, I believe that it will be useful to all our participants. Hope that all of you have enjoyed this webinar. Tony is really a nice speaker, and with these examples, I think that it was really interesting to all our audience. Tony, do you have anything to add?
Well, thank you very much indeed for your time. I do hope that was useful, and perhaps see you again on the next one. Thank you.
Goodbye. See you.
Goodbye.
Dear participants, thank you very much for attending this webinar. Follow us on our official website, www.asadriata.com. You can also follow us on our social media, Address Security Summit and A&S Adria Magazine on LinkedIn profiles. Thank you very much. Goodbye, and see you in September on our next webinar. Goodbye.